This episode brought to you by Rotate. When one reverse isn't enough, try 3 reverses with a Rotate. Welcome to episode 121 of 𝗟𝗡𝗡𝗪. I'm your host, Connor, and today with us, once again, we have our only panelist, therefore promoted to co-host for the time being, Adam. I guess we'll go around once again and do brief introductions from our just one panelist and co-host. We'll throw it over to Adam.
Yeah, so I'm 𝗟𝗡𝗪𝗆𝗪. I have been using APL pretty much my whole life, and I am now the head of language design at Dialog, where we do the cutting-edge APL development.
And as mentioned before, my name is Connor, host of 𝗟𝗡𝗡𝗪. We're back. I think this is the 3rd episode since we've been back. We took a 3-month break. We had our first episode, I believe it was in February, and we called that the Phoenix episode. We never even mentioned it, but, rising from the ashes of the first era of 𝗟𝗡𝗪𝗡𝗪. And then we planned to do a couple episodes, or a few episodes, I think we were saying, 5 plus or minus with just Adam and I. But then in the first conversation that we had back, I discovered, I had not heard of Fix APL by 𝗔𝗿𝗍𝗆, and we ended up interviewing him in the last episode 120. And now we're back with episode 121. We're going to be talking about a number of different things. We're going to talk about the word arbitrary. We're going to talk about notation as a tool of thought and how it mentions PEDMAS, which I was complaining about in a different podcast, and I guess the last podcast as well with Jacob. And we're going to be talking about short scope, long scope, and the precedence that does exist in array languages. But before we get to all those topics, we are going to have, I believe, 1 or 2 announcements from Adam. I can't actually remember the correct number, but I'll throw it over to Adam, and he will do the announcements for today.
Sure. I think I only have 1 announcement, unless you count that as an announcement. And that is that Dyna 26, so this is a Dialog North American meetup. It's going to be on Monday, the 27th of April. And its website is now fully up and working. You can look at dyna.dialog.com. There are summaries of abstracts of all the talks that are going to be given, and all the speakers and who they are, and all the information is there. And you can also register for the event now on that page. So go check it out if in any way you are able to be there, or if you're just interested. It's free, by the way.
Awesome. Free is always the best price. And as always, links will be in the show notes and in the YouTube description when it gets updated later. Speaking of links, I guess this is a quasi-announcement. We did mention, I believe it was last episode, or maybe it was in the first episode that we were back, that we were in the process of fixing links as we ported the 𝗟𝗡𝗪𝗆𝗡.com website from the Squarespace where it was hosted to now the GitHub pages. We were fixing a bunch of stuff, and then there was kind of like 3 different tiers. We fixed the first set, then the second set, and then it turns out that we had missed like a couple different things. Anyways, thank you to all of the folks in the APL Farm Discord or other places that reached out letting us know. I think, knock on wood, that they're all fixed now, but if you ever encounter a broken link, just let us know, and it's easy enough to set up a redirect to the new domain. With all that out of the way...
So that's actually another announcement that we're being reminded in the chat. You can look there. And that is that University of York has an exhibit called APL at 60. So we will... It's a little bit complicated to actually find the information about it online. So we'll have a link to that. But there's a specific exhibit that goes on that, an APL turning 60 years at York University.
Awesome. We will, find a link for that and link it in the show notes. And yes, if I think we probably failed to mention this on episode 120. We definitely mentioned it on episode 119. We've got a new format. I mean, if you're a regular listener and you listen to 119, you know this, but we'll just remind folks, we are on YouTube live. Meme God, aka Max, a professional probably the world's newest. Actually, we don't know that anymore because I think the company that Max is working for hired several APL developers. But Max is a professional APL developer. I get comments on the YouTube videos all the time. Is this language useful? What is this paradigm? Performance, blah, blah, blah. Yes, there are people being paid out in the world to program in array languages. And you can tune in live. Subscribe to the YouTube because we don't have a regular time. This is the second time on 3 p.m. Eastern time on a Saturday that we are live streaming. But if you subscribe on YouTube, you'll get notifications. We usually try to post these live stream announcements a week in advance. And if you don't want to subscribe on YouTube, follow us on some of the socials. We promote it on basically every platform we're on. And then you can hang out with us, ask questions, and provide us, links or prompt us to say stuff if you're live in the chat. If you're listening to this on a podcast platform, you can go to, the YouTube comments afterwards. And I believe also we have the GitHub discussion set up now, so if you want to leave comments there. Anyways, anything else to say, Adam, before we hop in today's smorgasbord of topics?
No, I think we're all good.
All right, so, if you're watching on YouTube, we're showing some code on the screen, but we're going to kind of ignore this for the moment. And the first thing I want to talk about is the definition of the word arbitrary. At one point in the conversation with Jacob, talking about fixed-APL, which is an APL, for those of you that haven't listened to that episode, that has fixed arity. So now we have two array languages in the Iversonian array language world that have no ambivalence and fixed arity. The first is 𝗦𝗛𝗢𝗪 by Kai, and the second is fixed-APL by Jacob. I think. There actually might be others out there, and if there are, please let me know about them. But these are the two that I am aware of right now. And in that discussion, I remember listening to it while I was on a run afterwards. So, I was in the episode. But then I always like to, after it's published on the podcasting platforms, go and re-listen to it just to make sure, because one out of every, I'd say, 75 to 100 episodes, I do some last-second change and it messes up, and then there's a gap for a minute. Anyways, I like to catch those fixes. And while I was on my run listening to the discussion, at one point, Adam, you say that the decisions that Jacob is making with respect to the kind of arity pattern matching, that they're arbitrary. And then I kind of pushed back in the episode and I say, well, what does arbitrary mean? Isn't it just the meaning that we attach to things? So isn't everything arbitrary at the end of the day? And then that back and forth led me to think what is actually the formal definition of the word arbitrary? And I went and looked it up, or maybe I've even paused while I was in the middle of my run. And it was that it is either random or on a whim. And when I read that, I thought to myself, including me, this is not just you, but we throw this word arbitrary around way too easily, because if there is a motivation for why someone does something, even if you disagree with it, or even if you think that it was kind of a motivation that was pulled out of nowhere, that therefore it's not arbitrary. So just because
I'm not sure where do you get that definition though? Because I just searched for it now online, and that got me the American Heritage Dictionary of the English Language, and it has 3 meanings for arbitrary. One is, like you say, determined by chance, whim, impulse, not necessity, reason, or principle. Another meaning is that it is subject to individual judgment or preference, and that's more the meaning that I have in mind here. Of course, unless you're designing JavaScript or something, then your programming language is not going to do arbitrary things. Sometimes programming languages can have undefined behavior where the implementers can do whatever in certain special cases, but usually you don't just haphazardly throw definitions into a programming language. But with arbitrary, I meant more like this, right? There's nothing that dictates it. There's no sort of formal rule or reasoning going into it. Just I would like this functionality to be here. This makes sense to me, so I'll make it like that. That's what I meant by arbitrary, not random, obviously. And there's the third meaning, which has to do with arbitration, but that's nothing to do with this. Okay,
yeah. So if you just, it depends on your browser settings, right? Google's always customizing things, but for me, when I put define arbitrary, Google has a little thing before all the links that uses the Oxford languages definitions. And that one, the first one, is based on random choice or personal whim. If I go to, I can't remember which one you said, but Merriam-Webster has a second definition that says based on or determined by individual preference or convenience, rather than by necessity or the intrinsic value of something. I would still say, like, I know that there was one case where I think Jacob had like two different options, right? Like if you are arity matching on whatever, some pattern, but there's two different ways and you can just like commute them. It's like, which one do you choose? You know, maybe you can say that that's individual preference, but I think a lot of the times the patterns that Jacob was choosing were actually motivated by, I don't want to say intrinsic value, because intrinsic value to me, like the semantics I have attached to that are like, it's anyways, but I don't know. So like, instead of saying necessity or intrinsic value, just say that like, what is a better way? Like motivated by reason, like there's, and that's not like, that's not personal reason. It's like the same way that Kenneth Iverson chose the S combinator and the phi combinator for the 3 train and the 2 train in J. Like we ended up changing the 2 trains to be not the S combinator, but the B and the B1 combinator. But initially you could see like the motivation and the reason for why he would choose those. You wouldn't say that he arbitrarily chose, 2 different combinators, or technically 4 different combinators to map to the monadic and dyadic 3 train and the monadic and dyadic 2 train. This is all to say that like, and when I say it's not just you, like I had the motivation to look up the definition of arbitrary when I was re-listening to this, but I also throw around the word arbitrary whenever talking about PEDMAS, which will be our second topic. And I always say, oh, it's arbitrary. And then I was talking about this. I mean, we talked about it last episode in 120, but when I was talking to Ben in one of the more recent ADSP episodes, I was whining about PEDMAS. And then someone in the GitHub discussion, I can actually go bring it up if I want to get the individual's name, but I was so thankful that they did it. They pointed out, I don't know if it was a he or she or they, that PEDMAS actually, probably the motivation for it was making polynomials more succinct and easier to write. And I thought...
Because it makes the order of exponentiation first on the x squared, right? And then you multiply how many of the x squared, and then you add it to the other terms that are there.
Which is like, I had never in my life thought about the way that we express formulae and like polynomials. Like for one, we omit, or what do you call it? You not imply, you suppress the multiplication, which is very interesting. Because if you think about like polynomials, it would look uglier by putting all the multiplications not only in between all of the coefficients and the variable names, but also the variable names. Like if you think about the quadratic formula, if you explicitly spell that out, you have to go, 4 times A times C, and like you can omit 2 multiplications. Anyways, the point being here is that this individual pointed out that writing polynomials in a more expressive manner was probably the motivation for it, and therefore I should stop saying that like the reason for PEDMAS is arbitrary. It was not arbitrary. And I even mentioned in that discussion with Ben that like maybe I should go and find the reason. And I invoked Chesterton's fence, which is this, it's not a law, but it's just like a remark. There's a Wikipedia article for it where the idea of like before you tear down a fence, you should go and figure out why was the fence put up in the first place, because there might be a good reason for it. And this happens with code all the time, right? Like we're looking at it and we're like, we're going to refactor this. And then you always hear about the artifacts of like putting the little comment that says, I also joined the group of people that tried to refactor this and realized that it's written a certain way. Anyways, this is all to say, arbitrary is a word I think we should throw around less, and we should...
Or at least be clear what we mean when we say that, right?
Yeah. But I do think that a lot of the choices that Jacob made were not arbitrary. They were motivated by reason, or, maybe we have to come up with a better word than reason, because I don't like intrinsic value or necessity. It's not necessary for Jacob to do it a certain way, right? Although in some cases, I guess if there's some other ulterior motive, like you're trying to... depending on the pattern, like the arity pattern matching, if you do something one way, you might prohibit a couple other cases, right? So like the way that you set up, like the pattern matching and the sequence of how you try and match stuff might enable you to match on more things, right? Which is, anyways, I'll stop talking. Or thoughts on that? Or maybe it's not, you don't have too many thoughts, and then we can just talk about
Well, no, I mean, yes, there is that with the polynomials, but that's and polynomials, I guess, are common in certain areas. A lot of what we do is not polynomials, obviously. S- And it's as mentioned in the chat as well. That it is mentioned in notation as a tool of thought as well. But that's not how we write polynomials in APL anyway. So it doesn't really matter so much.
Yeah, I mean, this was. Oh no. Oh, there we go. Yeah, this was also so in the same GitHub discussion. Max was the individual that also just pointed it out in the comments or the YouTube live stream. And this is, I mean, you gotta love learning, folks. Ben, one of my co-hosts on ADSP, at some point in the past, you know, we always exchange book ideas, and one of them is 𝗔𝗿𝗏𝗪𝗔𝗔𝗍𝗔, the history of like mathematical notation or something like that. And I had never picked up on the fact that Iverson explicitly mentions 𝗔𝗏𝗪𝗔𝗍𝗔, the author of those books, in section 5 of Notation as a Tool of Thought. And in that GitHub discussion, Max linked to section 5 of the Turing Award paper, Notation as a Tool of Thought. And it literally, I mean, I have to scan a little bit for it, but it literally says in section 5, the conclusion of this paper, that the reason for PEDMAS, and he's arguing that the kind of linear evaluation of expressions is easier to grok and makes more sense. But that the reason for it is because of polynomials. But like what is written in a textbook isn't really executable, because once again, if you go back to the quadratic formula, and he even points it out somewhere here, I should have prepared and actually like highlighted the spot. But he points out that in a mathematical formula, like the quadratic formula, you can't actually omit multiplication. I mean, you can when you're writing it on a page, but it doesn't make sense for executable like a program, because
it could.
I mean, but AC, you'd have to have a special set of rules, right? Like the fact that AC shows up together.
Traditional mathematical notation has a lot of arbitrary rules, like just the position of certain things implies multiplication. Not of everything, because if you write 3, 4 next to each other, that means 3 times 10 plus 4, not 3 times 4. Right?
I mean, is that, once again, though, is that arbitrary? Like, it's very, it seems to, like, obvious to me as soon as I see that, and, like, why does 3, 4 spell 34 and not 3, 4, is because of the way that, like, literal integers work. Whereas, you know, in a mathematical formula...
No, it's the other way around. You've been trained to read 3, 4 as 3 times 10 plus 4. But that's because they taught you that in school. There's nothing, it's not intuitive. It's certainly not as intuitive as 3x, meaning 3 times x, because that's how we speak. 3 elephants is 3 elephants. You don't say 3 times 1 elephant, right? Or 3 times a elephant. Look, mom, over there, 3 times elephant. No, you say 3 elephants, 3x, that's fine. But 3, 4? That's because of our positional system, which is a relatively new invention, right? A lot of places, they had separate symbols for larger entities or other systems to sort of combine things. Right? So Roman numerals, you have other symbols for larger entities. In Hebrew numerals, you have other symbols for larger entities, and then you put those together, which makes sense. If you want to say, you say 1 elephant and a mouse. You don't say like some mouse, and then that means like the first mouse should be multiplied by some factor.
My mind's being broken right now. You're saying that the juxtaposition of, we'll say characters, but what I mean by characters in this case in the base 10 number system is numbers. but digits we'll say.
variables and named constants and so on. Well, digits. But the funny thing is that you're in normal, the way people write normal traditional mathematics, you can write 3x and you can write xy, and that implies multiplication. But if y is 4, so and x is 3, then supposedly you could substitute in their values for the names. So instead of writing xy, you could write 3, 4. But that's not what it means. 3, 4 actually means 3 times 10 plus 4.
But isn't that the way that like numerics have always worked? Like you mentioned Roman numerals, but like the way that Roman numerals work is not like when you see like, just to be simple, x1, like that's not 10 1. Well, I guess actually it is. That's a bad example.
It is exactly that. That's how Roman numerals works.
Yeah, but there's a formula, right? Like if you put the
there's a little bit of special rule that has been formalized later after Roman numerals sort of went out of favor. People started making more formal rules that you can have subtraction on one side and addition on the other side. But like the basic system is just that you have I for 1 and v for 5 and x for 10 and so on, and you just add them up. Right? Add them up next to each other. You just start with a big end and write it out. Then people had like shortcut rules to do subtractions and things, and it was made more formal very late. But the basic point is that big units, and I always means 1. It could be +1 or -1. It never means 10 or 100 or 1,000. Right? For 10 you've got x, and for 100 you get c, and for 1,000 you get m. Right? Those are the names of the entities, and they are what they are. Right? And if that's how we were. But their juxtaposition doesn't mean multiplication at all. Their juxtaposition just means addition or subtraction, depending on the which side they're on, which one is bigger, that kind of thing. But if you try to formalize the rules in mathematics, you need a special rule for the formation of numbers, because with the formatting. Because if you start off with the rule that xy means x times y, and x has the value of 3 and y has the value of 4, and we also have a rule that says you're allowed to substitute in values of named entities with their net values themselves, then you must conclude that 3, 4 means 3 times 4, but it doesn't, because we have another overriding rule that is number formation, which says that adjacent digits have a factor of 10 applied to them. So with the further left you go, the more times you multiply by 10. And if you have a decimal separator, then that's a fixed point that tells you that below this is tenths and hundredths and so on. But that's a whole different rule set. And all these, we are so used to the way things work today that we don't even think about it. But it wasn't always like this, and it wasn't always like this everywhere on Earth. That's another thing that we're so used to are the symbols that we use, even in, say, APL and so on. We have a little bit of interesting thing going on with computing because of limited character sets. People started using the asterisk for multiplication, even though that was not a traditional multiplication sign. I think there's actually somebody that used it somewhere in the past, that used some asterisk type symbol for multiplication. But generally, it was either like an X type symbol or a dot. And the dot could be placed different places. It could be a center dot. It could be a bottom dot in some countries. There's been some unification, but things are not at all universal. So the symbol U probably associate with division in proper mathematics, like the one we use in APL. That symbol traditionally in Denmark means minus. Okay? And for division, we would use a colon traditionally. Things are not at all as universal as you might think. And when you like, oh, this is obvious how things work. No, it's not. It's just because it's been drilled into you from you were little how things work. Yeah. Even the plus symbol is not universal.
Yeah, when you were saying, when you remarked that it's not intuitive at all, I was thinking like, well, what is the alternative if you don't have I mean, there's many alternatives, but if you don't have these base 10 or even like a base number system, you could think of the way that we don't often, I don't ever have physical coins. I honestly can't remember the last time, but at a certain point in time, loonies, toonies, quarters, dimes, pennies, nickels, that's how you would pay for stuff, right? And that is more similar to the basic Roman numeral system, where if you need 37 cents, you need a quarter, a dime, and 2 pennies.
Yeah.
And
Well, those are cleverly chosen. All numbers, all what's called numismatic systems, coin systems, and stamp systems are very cleverly designed to make it's because it's actually like a knapsack problem to put them together. But if you choose your values properly, you can use a greedy algorithm. Otherwise, you get really stuck. Imagine if you had like weird, like prime number values on your coins. You had to pay out some amount. You're trying to figure out like what's the easiest way to pay this by combining, your $7 bills with your $13 bills and your $2 bills, and then it gets really complicated. So we can choose the systems to make it easier. But yeah, we could have such a system, absolutely. An interesting alternative that you probably haven't seen is the Hebrew one. That one is used daily by many people. They use the letters of the Hebrew alphabet, and the letter values are in the order of the alphabet from 1 to 10, and then after 10 you go 20, 30, 40, and so on up to 100, and then 200, 300, and 400, and there is some extension that goes 5, 6, 7, 8, 900 as well, but it's rarely used. And it doesn't matter which order of the symbols at all, not like Roman numerals where you can't just switch things around. You have some freedom in Roman numerals, but not total. In Hebrew, it doesn't matter which order at all you put the letters. There is sort of a standard, but occasionally it will spell out a word because pretty much any combination of letters in Hebrew spells out a word. And sometimes it spells out a word that you want to avoid, some bad word. And then people will just switch the digits, so to say, around because they want to spell something else instead. That's a whole different way of working. But it's fairly easy, intuitive to understand because every letter always has the same value, no matter where it is. And as pointed out in chat, yeah, the base system isn't given either. Right? 3, 4 only means 3 times 10 plus 4 because we use base 10. But there are many other bases we could be using, and have historically been other uses, other base uses. For example, traditional English system seems to be 12, right? American measurements and names for various things. You count in dozens. That's base 12. Base 60 was used in Babylonia, and that we get our time counting from base 60. Right, 60 seconds in a minute, 60 minutes in an hour.
Yeah, this reminds me too of, man, it's so much food for thought. It reminds me of, at one point I kind of realized that due to rank polymorphism in array languages, mapping is explicit. And when I was looking at different closures or different Lisps, one of which is closure, but there's scheme and others. In certain dialects of Lisp, the reduction is implicit. All you have to do is put the binary operation in front of a list of numbers, and the reduction is implicit. And it kind of makes you think, I think of reductions.
Didn't we what? We had that in 𝗏𝗏. We have spoken very little about 𝗏𝗏, but if I remember right, when you actually were earlier when you said the only 2 languages we're aware of that don't have ambivalence, but if I remember right, 𝗏𝗏 actually sort of doesn't have ambivalence. It sort of has, in that you can call the same function monadically or dyadically, but it's actually the same function whether you call it monadically or dyadically. It's just an infix version of it and a prefix version of it. If I remember right, because I'm not good at 𝗏𝗏, a prefix plus is a sum, and the infix plus is what we know as normal plus. But that's the same function. They're not considered different ones. It's not, oh, this is how you do reductions, this is how you do addition. It's just the same function being applied in 2 different ways. So it's not ambivalent. It's always means the same thing.
Right. It's very curious. Yeah, and the thing that I was going to link it to was that if you have integers, well, I mean, I guess actually it's not just that it's multiplication. There's there's the whole, whatever base you're in, you do exponentiation.
Yeah, but we don't think about it.
Yeah,
but
yeah.
a computer scientist that sits and deals with a memory dump, he sees 3, 4, and immediately goes 52, right? Because 3, 4 in hex spells out 52.
Yeah.
One thing that a lot of people see is in a URL, you will often find the number 20. That means space, but it says %20. But that's because space occupies position 32 in the ASCII table. Okay? So 20 means 32. But APL's notation for polynomials is so much better that that argument doesn't hold. Right? Instead of writing this awkward, like whatever the drive principle, right? Do not repeat yourself. So we go 3x squared plus, 3x squared minus 5x minus 7, or something like that, right? Mm-hmm. But we're repeating x. That's redundant. The x that appears in x squared and the plane x is the same x. Why do we have to repeat it? And all the pluses, they're also repeated. So we elided the multiplication to sort of get a little bit of conciseness, but it's still like the pluses and the minuses, they're even confusing, because when you said 3x squared minus 5x, actually what's going on here? It's actually plus -5 times x, right? It's not really the terms that are being subtracted from each other. It's just it's actually adding a negative entity there. So the APL notation for 3x squared minus 5x minus 7 is x decode or uptack 3, -5, -7. That's so much better. You can see what is the variable we're dealing with. That's x. And then immediately you have the factors: 3, -5, -7. They're right there. It's a vector. You can deal with it. You can modify it as you want. If you want to scale up everything, you can scale that vector.
Yeah, and for those that are listening to the audio version, we're looking at part of section 5 is notation of 𝗔𝗿𝗆𝗪. We'll put it in the show notes.
It's not even what you're showing on the screen. Doesn't even have that. He just factors out. No pun intended.
Yeah. But I mean, what you were saying is loosely inspired. At first, I thought you were referring to this, and then I realized you were just talking about
going all the way. You don't think does he have that in the paper? If you keep going, does he? You have the plus the times. Put it on. No.
No, this is just section 5, right? So.
Yeah. I don't remember.
Anyways, I mean, we don't need to.
It's been there originally.
The point being is, what is the point? The point is lots of things to think about in the future. We should, whenever we say the word arbitrary, we should, or at least I want to take a step back and potentially in the moment, if we're recording a podcast, we won't know the reason, but I don't know how many times on a podcast I've whined about PEDMAS, but I think about it frequently. When in that conversation with Ben, I said, I will never forget being in that meeting with a colleague, and he made the argument that, we teach it in school and therefore it's better. And that'll stick with me for the rest of my life. And I never even thought at any point in time, except for, I guess, when I was talking to Ben, that maybe I should go in Chesterton's fence, go find out why. Is there a reason? And then luckily someone in the GitHub discussion pointed it out. And then Max, who's in the chat right now.
It's the reason. It's just a bad reason.
Yeah. But that's the thing is like even that it doesn't necessarily mean, or it doesn't matter that it's bad or good. I guess my thing is that when we're discussing something, to call something arbitrary is like I think it's like condescending to the idea. If there actually was like a bad reason is better than no reason. Is that true?
Okay, for sure.
I mean, we can agree about that.
No, I think a bad reason, at least there's a reason for it.
Exactly.
Like if you want to talk arbitrary, like comparisons of things in JavaScript, right? That's just totally arbitrary. There's no rhyme and reason to anything. You can't rely on it. It's just bad.
I'll take your word for it. I mean, I code in JavaScript, but by I code, I mean the AI codes for me, and I don't know JavaScript well enough. But I saw the table, and I can take your word for it.
Yeah, the equal operator in JavaScript is so bad that they added equal, right?
Yeah.
It's not equal isn't perfect, so I'm waiting for the day they're going to add equal to actually fix comparison. But maybe one day they will. Right. So that you've got there are cases where things are truly like random, and it just seems like you can't rely on this because you can't really reason about it. There are things that are reasons that have good reasons. There are things that have reasons that you could argue with the reasons. I remember 𝗔𝗍𝗪 was frustrated at having to disclose after applying a reduction on a nested array. Mm-hmm. So let's say you've got a list of pairs. And you want to add that list of pairs together to get a single pair, right? So the first element of every pair gets added together, and the second element of every pair gets added together. But at the end, in the floating array model that Dialog and APL2 and so on have, you end up with a scalar, because you go from a vector to a scalar, and reduce must lower the rank. So it goes down from 1 to 0, so you get an enclosed 2-element vector. But you actually just want the 2-element vector. And 𝗔𝗪 said, I always want to disclose. So 𝗔𝗪 APL just does that disclose, if I remember right, out of convenience. It's sort of arbitrary. There could be cases where that's not really what you want, but it's a personal preference. There has a reason to it. That's what I always want. But it just sort of makes it harder to reason about certain things. There are,
but I mean,
you could
isn't
say
convenience
design
a
mistakes.
reason?
Yeah, convenience is a reason. Here's another one.
But it's kind of arbitrary. Like it's either arbitrary or it's not, right? Even if it's a bad
no,
reason that you
but
don't
that
agree
depends
with.
which meaning of arbitrary, right? That is it random, or does it have reason but maybe not the best reason? So one thing that I find very regretful is that APL did not have the tally primitive from the beginning. So when getting the length of a vector, especially, people would use the shape primitive. But shape always returns a vector. For a vector, a one-dimensional array, it returns a one-element thing. And this was so common to use the result of the shape of a vector, which actually gives a one-element vector when really you wanted a scalar, that a lot of the design of APL allowed one-element vectors to be treated as if they were scalar. Later, when APL was extended, especially to nested arrays, that came back and bit them. And now there are weird design flaws they look like. But was there a good reason to do it? To allow one-element vectors? Yes. With the very limited functionality there was in the old APL, it was sort of hard. And if you're not allowed to use any new features, relatively new, any features post 1980, how do you get a scalar length of a list? It's sort of awkward, right? There was no 𝗔𝗐, so you couldn't do 𝗔𝗐 reshape the shape. So you could do quote reshape, but that's sort of a type error. That's also convenience. How can you use a string as a shape? That makes no sense either. That's another convenience you're relying on. So you have like a parenthesized iota 0 reshape. Where to get the first element of something, people didn't have. You couldn't do left tag reduce. You couldn't do first. You couldn't do one pick. All of that didn't exist. So people did one reshape or one take. You get a vector. Okay, so for convenience, a lot of vectors were allowed in places that really shouldn't have been. And that has then that, don't have to go into all the details of all the mess that made, but that has made a lot of mess and a lot of issues in various places. Was it arbitrary? It wasn't random. It was deliberate. They had to go out of the way to define things to work with one element vectors. They had a reason. The reason was sort of good at the time. The reason became bad later when APL was extended. So you can have a reason that goes from being bad or not justified anymore, we could say. The reason was still good, the reason they had, but it ceased to be justified. But now it's already there. You can't really go and change it.
But so you would or you wouldn't call that arbitrary?
I would call it arbitrary, but definition 2. Chosen because of convenience and personal preference. Not chosen because it falls out of the logic employed. There's nothing about the language that makes it reasonable to treat one element vectors, or even worse, singleton, any one element array, as a scalar. It's only out of convenience because of shortcomings other places in the language. So we allow that.
Determined by individual preference or convenience. Is that individual distributive? I read it as distributive, meaning that it's individual preference or individual convenience. Is it to you?
No, I mean, it could be, but I would say even I don't think the individual here, I would restrict on that in arbitrary. You certainly can have a committee that makes arbitrary choices. And that doesn't matter if the individual could apply to a group of people, I would say, for this kind of thing, where it's designed by committee, whatever. And what is convenient for me, ultimately somebody commits the source code that causes the behavior, but what's convenient for this person might very well be convenient for somebody else as well. And a lot of people would have hit the issue with one element vectors. I'm sure there was something that very quickly discovered and decided, yeah, we need this.
Well, what's funny is that the word, like, semantically, the word convenient is like so far from arbitrary in my mind. And then I just Googled it. I guess, there's multiple definitions, but the state of being able to proceed with something with little effort or difficulty.
Yeah.
British English, it's a public restroom. But like I find, because like it's odd now. So we have the word arbitrary, and then now in the definition of one of the definitions of arbitrary, there's the word convenient, which you're using. It's convenient, and maybe there was a good reason at the time, but it became bad due to the evolution of the language and the glyphs that were available later. But in my mind, also, like, convenient is also like a step away from practical, which is like the delta between, 𝗏 and some of his choices in 𝗦𝗛, which I tend to lean towards, versus Marshall and his pragmatic design of BQN. Like, a lot of the times, there's a choice. You can do something that is less, rigorous and more pragmatic. But, or is pragmatic the right word? Jesus, we're just in a like a
questioning the meaning of all the words.
All the words, it's where something is like, more rigorous. Like,
you can have something that's more rigorous, that's more sort of strict, maybe fewer rules, maybe, and then you can be pragmatic and say, no, for convenience. That's sort of I look a lot at the contrast between APL and J like this. J was designed with the lessons learned from decades of APL usage, and J is more rigorous. J is more consistent. J is less pragmatic. And I think I have the feeling also from discussions. I can't say it from personal experience because I haven't learned enough J and used J in anger that I could really compare the experiences. But my feeling is that as a J programmer has to spend more effort sort of navigating the hard edges in the language, Not as in like weird edge cases, because it has less edge cases, but because it's less pragmatic in certain things, then you have to be more exactly aware of what's going on. You can't just gloss over details of the array model the way APLs do. The fact that if you enclose a simple scalar in APL, it just stays itself. It leads to some inconvenience on occasion or some special things, but most often you just sort of don't think about it, and it just works. Everything just works. And this problem, an attempt at addressing this problem was the based array model that BQN has. I don't particularly like that solution. I realize the issues with the array model that the APL2 or NARS array model that Dialog uses. I don't have a good solution for it. But I don't particularly like what's in BQN, that you can have values that are not arrays. That bothers me in an array language.
All right, so just to clean up the word salad, the definitions that we don't have, I should not have, put on opposing sides of the fence the words pragmatic and practical. Those are here's the definition, one of the definitions we should say, of pragmatic: dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. So the word pragmatic invokes the word practical, and then I realized, oh wait, the word I'm looking for is principled. Rigorous and principled versus pragmatic and practical. And I tend to lean towards, I prefer the more practical and pragmatic things. And then this just brings us back to the whole, we've got arbitrary, and then we've got, a step away, technically right in the definition, the word convenient. And then from convenient, we have practical and pragmatic. And people might be wondering at this point, why are they spending 40 minutes talking about the definition of the word arbitrary? I think this stuff is important, folks. Just right when I stumbled on trying to describe we'll call it 𝗦𝗛 versus BQN, but really it should be 𝗏 versus 𝗏𝗏, because I know 𝗏 says that it's a community project. It's not just his thing at this point, but it's important, the words we choose, because now that I think about when we're in 𝗏𝗏 and you're overloading the arity, or fixed APL for that matter, or even K, because we apparently discovered in K, or I discovered that K makes this choice a lot of the times. When you dispatch on the arity of something, to me, that feels convenient. The reason I want, the thing that I was thinking of, and we'll transition to talking about the echo chambers problem and long and short scope in a sec. But this came up in that, after I posted the second follow, so just in case someone doesn't follow me on YouTube, 2 videos ago I posted a video solving a problem called echo chambers, which is given a string like ABC, transform that string into a string where you copy each character in that string the number of times that corresponds to the one index of that string. So if you have ABC, you copy A once, B twice, C 3 times. You end up with A, B, B, C, C, C. Anyways, I solved that video. The best solution had, I think, 5 characters. And then a bunch of people provided other solutions. I made a follow-up video. And in that follow-up video, someone had pointed out that any language that has prefixes, which is different than scan, and a lot of the times mentally I think of them as the same thing, and they are very different, folks. They're very different. One takes a binary operation and performs a reduction on the prefixes of a sequence or an array. The other takes a monadic operation, which if you want it to have the behavior of scan in other languages, you have to explicitly use or pass a reduction. So, in APL, dialog APL, you go plus scan and you get the expected behavior. In J or in TinyApple, because they have prefixes, you have to go plus reduce scan. And that to me hurts my soul. It hurts my soul. I don't know why it hurts my soul, because it's an extra character, and I started learning APL, and I have a fondness, soft spot in my heart for the fact that reduce and scan are symmetric. They're visually symmetric, and so when you require prefixes to take a monadic operation, it's just not as beautiful. And then someone pointed out in the comments to that video that the binary overload on the arity of tuples. So tuples in 𝗏𝗏 is a modifier, And because it has fixed arity, it can do different things depending on the arity of the function that you pass it. And so someone mentioned that tuples, in the case where it's given a binary operation, is prefixes. And I thought to myself, wow, wouldn't it be nice if you had in an array language, a fixed arity array language, the scan, \, and if you pass it a monadic operation, you get prefixes. And if you pass it a binary operation, you get scan. And I'm saying all this to say, is that just me reaching for convenience? Is that is my desire for that arbitrary? In my heart of hearts, it seems like I have a really strong motivation here. I understand why like prefixes is the more general glyph or primitive, because what if you want to perform a monadic operation like reverse on the prefixes? In APL, you're going to have to do what? Comma scan. Is that accurate?
Yeah, there is no good way to do prefixes in the APL, because comma scan only works on simple vectors, and it doesn't quite give you what you think it gives you anyway. It often works. In this case, it still works. Yeah.
So, but if you wanted to do reverse, you could do a reverse each comma scan of a string. But the point being is,
or you could use comma commute.
Well, actually, here let's go back to where's my array box? All right. So we got some code. We've now transitioned. That was a wonderful discussion. Yeah. Will we talk about the definition of arbitrary and pragmatic and practical and principled and convenient in the future? Potentially, folks. Potentially. And let's go to. And so actually, let's take 2 seconds. This is the BQN solution that we're going to come back to in a bit. That requires parentheses, folks. The reason why I have BQN highlighted. So for the audio listener, we've got replicate with a back hook, and the parenthesized expression that is being passed to the unary operation for the back hook is 1 plus range jot length. And we don't have a 1 indexed iota, so that's why we have to do the 1 plus. And the fact that this needs to be parenthesized is what I find interesting because of long and short scope and how that applies to operators or modifiers and functions. But we'll come back to that.
You don't have you can spell it without parentheses if you want.
We can. But if you want to use the back hook, you need the parentheses. But now we're in.
But no, you don't. You can just compose the 1 plus.
That's true. All right. Well, we're going to come back to that though, folks. We're going to come back right now. So this is comma reduce. Here, right? So this is what I expected. We've got comma, scan, and now we've got our beautifully rendered in a nested list A, AB, ABC, ABCA. Yes, so the string that we're working with here from the Perl Weekly Challenge example, the first test case was ABCA. And if you wanted to do if I'm going to type this correct, a reverse of each, it's just reverse each, comma, scan. But wouldn't it be beautiful if you had no ambivalence, and you just had this, and you reverses a monadic operation? That I think that would be like I wonder actually what does 𝗦𝗛𝗢𝗪 do for scans function? You got to do scan on.
I was just trying this and then scan's on the left.
Yeah, I mean all of their modifiers are. I mean everything's prefix. Functions are prefix. Modifiers are prefix. And
I'm not used to using 𝗦𝗛𝗪. But if you go back to APL for a moment, it was something I just mentioned before that you can do. You can write comma commute.
Comma commute.
It doesn't solve your problem in general, but I mean in this case that's how I would do it.
Oh yeah, and let's just change this to D to make this. I was looking at the last one, and it started with an A, and my eyes were like, this is the same. But it was actually reversed. That is a cute trick. So yes, for this example, it does what you would like. But anyway, so what are your thoughts on, is it arbitrary? Is my desire to have a scan in a fixed arity APL that handles both monadic and dyadic functions as the dialog APL scan and the J prefixes, is that convenient and therefore arbitrary because it's what I personally would like? Or is there a strong enough motivation, or is there like a strong enough reason that it's not my personal preference that is guiding me to this. It's that prefix is useful, scan is useful. They're obviously related, so overloading on the arity of an function that you're passing to this modifier or operator. What say you?
No, I don't think. It's arbitrary. No, I think there's good reason to want both prefixes and scan.
Mm-hmm.
I'm not sure the connection between them is as strong as you're making it out to be. Because prefixes is there is no function that you can give to a scan to create prefixes. This is not prefixes what you've got here. Well, or if you remove the commute.
You're referring to like the simple vector case it works for, but in general it doesn't? Is that what you're saying?
It doesn't even work for the vector case. You can try it. Here, if you remove the commute for a moment, it looks like it's working well. I'll show you it doesn't. Here, and then you write. It's fine. You don't have to use a definition. It's fine. You can just write here shape each.
Shape each.
See, it doesn't actually work because the first element you got, which looked like it was just the letter A, is not a prefix of A, B, C, D because you got a scalar A. Why is that? Because scan starts by giving you the first element, and then it reduces over the first two elements, and then reduces over the first three elements. Now, when you took the first element, you didn't apply any operation to it at all. Therefore, since you started with a scalar A, the first element becomes a scalar A. The second element becomes an enclosed AB, because a comma reduction over a comma reduction over a two-element vector becomes a scalar. And because of the floating model, you sort of the scalar A at the beginning sort of looks like it has the same level as the other ones, but it really doesn't. So you go back to the APL one again, and go back and write, instead of shape each, write depth each. So like the match symbol, right? Yeah, and then you have to hold on. You have to put the comma in again. Yeah. Oh, that's a dot. Yeah, see, the first is a scalar, and the second one, the third, and so on are vectors. They have higher depth. There is no function.
Is this a dialog APL issue? If we go to BQN?
No, it's not.
So what is a
join? It's a.
I see. So
the first one is a scalar, and the second ones are vectors. It has to be. If you start by the first thing, unless you do something clever in scan where the first element is, or you find out what the identity element is, and you perform one more application of the function together with the identity element, that would change the scalar into a vector. But it gets even worse, because in our case.
Wait, pause before it gets worse, just for the audio listener, because we're kind of check out the YouTube for the full being able to follow along. But what we've been showing basically is that in dialog APL, if you do a comma scan, it shows you what looks like the prefixes of your string: A, AB, ABC, ABCD. But then if you it's a
lossy display form, right? It doesn't actually tell you the truth.
Right, exactly. And so if you do a shape on the prefixes, you end up with empty, and then 2, 3, 4. And if you change this to be the depth, you get 0, 1, 1, 1. So what we've been talking about is how the first thing that results from this quote-unquote spelling of prefixes in dialog APL actually doesn't match prefixes, because if you go to J and you do a count prefixes, you get the 1, 2, 3, 4. And I imagine if we do depth, we're going to get 1, 1, 1, 1. And we went to BQN to try the same thing, and I replaced the comma with the sideways S that is called join, I believe. And sure enough, the depth each join scan gives you 0, 1, 1, 1 as well. And so now Adam's about to tell us how it gets worse.
Well, there are various things that are getting worse because and Iverson dealt with or tried to deal with this in J as well. Really, some of what this comes down to as well is that you cannot substitute stranding with another function. Really, what you want to do here is if there was a function you could insert to get prefixes, it would be the stranding function, because all you want to do is build arrays for prefixes. You're not interested in performing any operation between the elements themselves. You're using catenation because that seems to be a neutral function that just keeps both left and right side. But in reality, it doesn't. Catenation, it breaks structure. It opens up things and joins them together. If you use the other that we don't have in APL or in dialog APL, but in BQN here, I don't remember what it's called. This tilde looking symbol. It's called join, but try using couple instead. Or not couple actually. Yeah, you could use couple or you could use pair. There are 3 of them in. Yeah.
Says
yeah, it doesn't work at all because it tries to stack them on top of each other. Okay, now use pair. See what's happening here? Looks very wrong, right?
Yes, it does.
So what happened here is that we're actually applying a function. You might not think of the catenation as being applying a function, but we're actually applying a function over and over again, and the function gets as argument the previous results in the sequence of running the scan, right? So if you look at the rightmost element, right, we can see that the last step it did was joining the D with the ABC part. The ABC part was constructed from joining AB with C. But because we are not breaking open the structure, we're just putting them next to each other, right? We now preserve what's actually going on here. That's this function application. So, and there is no function that corresponds to stranding. Really, all you want to do is you want to say, oh, on the prefixes, I don't want to apply reduction at all. So you found that in some cases you sort of get the right result by using a catenation, but that's not really, you really don't want to apply any function at all. So a scan is a reduction on each of the prefixes. But prefixes is not something you can define in terms of prefix is not something you can define in terms of scan.
Yeah, I guess.
So they're not.
Really, you want to do like the one indexed, bundle that, and then do like a 1 take, 2 take, 3 take, 4 take. But you can't.
Exactly.
You can't do that with a single.
There are other issues with prefixes versus scan. For prefixes, there are many possibilities. Well, multiple possibilities. Isn't the empty result also a prefix? Isn't the empty string a prefix of ABCD?
That's up for debate. I know that prefixes in BQN does that. Although prefixes in BQN isn't a modifier, it's a function. So
yeah,
to confuse the listener even more, in TinyApple and in J, it's a modifier.
Yeah, that's part of the philosophy of BQN, where you prefer functions that do a structural manipulation and then you apply to that. Whereas in J especially, they go very strong in on the operators that we or modifiers, adverbs that we apply to the results. But really, you can see that prefix, the J prefixes, is a compound operation. It's both finding the prefixes and applying a function to them. and emerging the result of that function application back into an array. So if you switch to J now, okay, well, and
There's no
no,
pair.
you don't have a pair. No, but the way you would get prefixes here is you would do the box, right?
Yeah,
Less
yeah.
than. But think about it. What actually happened here? What are we enclosing? What is this whole enclosing business?
What do you mean? I'm confused.
You're using box prefix, right? So this means on every prefix, apply the function box monetically, which box is enclose. Yeah.
Mm-hmm.
Why do we need to enclose? In the APL prefixes we're dealing with, we didn't seem to be enclosing anything. Actually, we did, because we ran a cancellation reduction. Reduction reduces from a vector to a scalar, so actually there is an enclosure going on here. But why do we need to box here? The reason you need to box, right? You would think that doing nothing. Why isn't it just the identity function, the right bracket? If you do that, you get a very surprising result.
Wait, do I not know how to type? I forgot how to type.
That works as well. Yeah, that's actually the left identity, but it doesn't matter in this case. So what happened here? We got a bunch of spaces. The reason is because actually the prefixes thing does 3 steps, at least from an APL's perspective, it does 3 steps. It finds all the prefixes, applies a function to it, and from an APL's perspective, mixes the result. So it built a higher rank array, adding a dimension that enumerates the prefixes, with the trailing dimensions being the arrays that we got out of the prefixes themselves. That's why you need to box, to counteract that. That when we built an array where each major cell is the result of one function application on a prefix, then if you box them, and then we get scalars, boxes, and we built an array with major cells of scalars, that's a vector. That's why you get a vector of the prefixes. It's very different.
Very interesting. We should maybe have a whole episode in the future, or maybe this was the mini episode in an episode called scan versus prefix, because this all came from me asking you, is my desire to have a monadic dyadic dispatch to scan and prefix, is it arbitrary because it's convenient, or is it not? And then you basically were explaining that, like, well, they're not as closely tied as you think. And potentially, even if you didn't think it was arbitrary, you'd say it's flawed reasoning due to this kind of separation.
I understand your reasoning, right? When you asked, that's why I didn't just answer one way or the other.
Right.
It's not arbitrary in the random sense. It is something you have a reason for. I think you have jumped a little bit to a conclusion on how related the things are, and so it seemed to you reasonable that they should be the same thing. But now that I've shown you that they're not as closely related as you originally thought, I would like to hear from you whether you still think they should be bundled together like this.
Oh, absolutely. Fantastic. Put them, ship it. Your response was fantastic. I didn't realize I was about to learn a massive amount about the differences between scan and prefix, and it's given me a whole new appreciation for why J has prefix, and certain languages reach for this. And I assume Tiny Apple has both, because they typically have everything under the sun. That being said, even though they are further apart than I would have originally thought, you can't implement one in terms of the other. If you draw, a mental map of the distance between different primitives, scan and prefix are still very close, even though that, you should keep this asterisk in mind that, you can't implement one in terms of the other necessarily. Well, I guess technically you could implement
one way, yes, but not the other way.
Unidirectionally, not bidirectionally, though. Although, a lot of...
No, you can't really implement prefixes in terms of scan.
Right.
It's limited.
But yeah, I still would like it. I should caveat that. If you are going to support both scan and prefixes, I think it would be nice to have them in the same glyph. The question is
and if you have fixed arity or something, or some other way
right.
to specify what's going on.
Yeah.
So interesting enough, a language that sort of has fixed arity is K, or at least you can very easily make a K that has fixed arity, right? There is the convention in K to use a colon after a verb, after a function, to say that interpret this symbol as monadic when you could be in doubt. And I believe, see, I'm really not good at K, but I believe that the scan is, or scan, the backslash, right, is overloaded based on the arity of its operand. It doesn't mean on prefixes or scan. It pairs up other things instead. It pairs, so if it's a function that you're using, then it means like, give me, let's see if I remember how. It applies and a number of times, I think. No, that's when the left. Let's go.
This is why, folks. Someone has asked both on the website formerly known as Twitter, now X, and in the YouTube comments of one of my recent videos, is there going to be K on ArrayBox? The answer definitively is yes. I am just busy, and I will say I know. Well, do I know the least about K? It doesn't matter. K6 will be coming to ArrayBox at some point, and then we could be doing this on screen right now.
So this is how it works in at least older Ks. That the reduction does the reduction, right? Plus slash means sum, and plus backslash means scan, the way we know it. But if you use a monadic function, then then it's fixed point, like in APL power match or power infinity in J. Right. So apply this function over and over and over until it's stable. Or you could define it differently as until you get a value you've seen before, so you don't end up in loops like that. But that's it. Yeah. Whereas the scan, in the same way as the scan gives you the intermediary values on the way to the whole reduction, it gives you intermediary values unto the fixed point.
Right.
Which and would you not agree that
when you need that?
Yeah. So would you not say that those are much more related to each other than unprefixes and scan?
The argument can definitely be made.
And think about it like this: you ideally you would, I'm sure you will appreciate the beauty of this, that you're treating forward slash and backslash, if you use those symbols, but we'll use that for now, just to be able to speak about them, as parallel to each other. So we need 4 slots in our table. It's a 2x2 table, forward slash and backslash, and then the meaning with a monadic operand and the meaning with a dyadic operand. In K, it works very nicely. Dyadic operand, it's the full sum. Monadic operand, it's apply until fixed point. With backslash, it's give me all the intermediary values until the full sum, and give me all the intermediary values until the fixed point. But let's say we wanted to go backwards from here and use your meaning with a monadic function. Okay, so backslash with dyadic operand means scan. Backslash with monadic operand means unprefixes. Forward slash with a dyadic operand means sum, and forward slash with a monadic operand means what? Apply.
All right. There's a very, very, very nice argument. Very well done. Yes, I see the beauty that you have. The symmetry falls apart, right?
Well, if you want to be consistent, then it would be the last value that you would otherwise get, right? So the last value on prefixes is the function applied to the entire array, which would mean that f forward slash is equivalent to f.
Right. I mean, so you technically could be consistent, but it's just a waste.
Yeah, well, I mean, yeah. Or maybe it would mean like an enclosed one. I don't know. Either way, it doesn't really work so well.
Interesting. All
So
right. Well,
now, Connor, let me ask you for the second time. Do you still think that this is a good pairing?
No, probably not. I mean, my major thought is that, wow, I got to go, there's not enough time in the day, folks. What I need to do is retire somehow so I can just spend all of my free time building all of these tools and learning all the array languages. Unfortunately, it's hard to retire at my age.
How
And
old are you?
I'm 35, folks.
Yeah, halfway there.
Halfway. I mean, ideally, I don't want to have to wait. What is that? 3 decades until I can do all this stuff. But it's all right. My main thought though is I need to go add K, and then we need to start talking about K more. And maybe the thought is if I have a fixed arity APL in the future, you just borrow a lot of that stuff from K, and then bada bing, bada boom, Bob's your uncle, and Bob actually is my uncle. But we have 15 minutes left to the hour and a half mark. And Max says in the chat, my retirement goal is the same. And also, we got a comment from 𝗦𝗛𝗢𝗪, who was featured in the follow-up video because they provided one of the nicer solutions, or maybe it was a couple of them. And they said, 𝗦𝗛 does not include the empty prefix to keep the same number of rows in the output as the input, which, once again, we must always ask the question,
sense.
is that that's not
No,
arbitrary?
but I mean, it's not arbitrary. But it is pragmatic, but it sort of makes sense, and there's a mapping, right, from this element to all the elements that preceded, right, including all elements that preceded. But there's a good reason. Pragmatically, you might I think BQN includes it, if that's true. I don't remember. Because it's easier to drop one than it is to add it in.
Right.
So,
all right, let's skip to the last topic for today's episode, which is
actually, there's one thing that maybe you can help me with. Let me have this. While we're still working on these prefixes thing, can you? Because I'm really not good at 𝗲𝗏. Maybe you can do this. How did you get the prefixes again in 𝗲𝗏?
Is tuples, which I don't actually remember. So tuples with a binary operation. So I think if we go box here, this will give us the prefix.
Okay.
Ooh, look at that. There's a bug, folks. A bug. That should be...
What's that bug?
Whoa.
Oh.
What is that?
That's fun.
What is this?
You can use 3 languages at once.
What in God's name? Well, for the audio listener, we've got 3 keyboards at once. I do not know how that happened, but we've got a bug here. We got to go fix this.
Code?
I was going to screenshot it, but then I realized this is being live streamed on YouTube, so no need to screenshot.
It's already screenshot. Okay, anyway,
Anyways,
we already
tuples
here.
box.
This is all good. Okay, now what happens if you transpose this?
Transpose?
Mm-hmm. That doesn't do anything?
Didn't seem to do anything.
Oh,
But this is a nested array, right? I believe.
Yeah, so you have to mix it first or something?
Most likely. I mean, we've got 𝗦𝗛𝗢𝗪 in the chat. Potentially, they can let me know.
So what I was getting at was, I think in 𝗔𝗿𝗏, which you're missing from ArrayBox.
I don't know if 𝗔𝗿𝗏's going to get added. Maybe not.
No, but in 𝗔𝗏𝗏, I believe you can do this, but if you get the prefixes and transpose, because 𝗔𝗏𝗏 uses sort of a k-array model, then yeah, no, but we can't do this. 𝗦𝗛𝗢𝗪 says in the chat, if you want it mixed, you use a fill value and tuples identity. But we don't want to do that. Because the idea is that if you were to transpose this, think about what you get if you transpose.
I would assume it looks something similar to... Well, I would just think it would look similar to a transposed version of what we saw in K when we were just doing the...
Well, I think that would be a zip, right? So you'd get A, and then
Yes.
you would get
Yeah.
BBB, and then you get CC, and you get D, which is very similar to the result where we want. Which means you could combine this with a reversal and flattening out everything, and you got the final result. I just show something that struck me, that it's a different approach completely. I just don't know how to write it in 𝗲𝗏, and or I mean, it doesn't work. It doesn't. It mix it up is up error, but it doesn't work because mix is going to add its on the y. It's going to pad with spaces. So if you wanted to do this, you can do it, but it's going to be terrible. You have to. It's a train too long. But you might as well switch to default form because you have to do a whole lot, right?
But isn't this what you were just describing?
Yeah, but we need more, right? Because you have to put in a commute on the comma because you want to do it in reverse, right? I think no, that's not even enough. No, that's not enough. We have to do.
I mean, wait, what were you trying to get towards? I thought this is what you were just describing.
Yeah, but I mean, it doesn't. No, I thought that 𝗲𝗏 would allow me to transpose, even though the elements are not. I thought it would transpose the vector, like to do a zip, basically. And I thought that they would allow me to do it, even though they have different lengths, and they would just make things work out, which I think you can do in Jelly, that kind of thing. I think if you try to transpose something that's mismatched lengths, it will just take the elements that are available, something like that. So you can spell it out. If you put in a brace now, we can do the motions, but it will get really ugly because this is not right. It's to do things. So you reverse omega first. No, hold on. What was the actual problem? You want to replicate by the length, yeah. So reverse omega. Now we get the 4 Ds, right? So now we can do the rotation, right? If you start reading from the rear here, you get A, B, B, C, 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 D, 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 D. Right? So you can do a rotation. You could do a the comma commute if you really wanted to do it. Do that, I think, unless no, that doesn't even work. You want to do rotations.
Can't you just?
That doesn't help you. You need to reverse, right?
All right.
So
well, we don't need to solve this here. Leave it as.
I mean, you can finish. You do a reverse first if you want at this point, and then you can do a ravel, and then you need to remove the spaces. What? No, just ravel. Just a single comma. Yeah, and then remove spaces. Quote, space, quote. Or actually, yeah. A crazy thing is you could do omega intersection. It's insane, but we can do it. As in, say, intersection commute. Sorry.
And then reverse.
Yeah, whatever. I mean, it's crazy, right? But you can get. I told you they're gonna get ugly. I don't think we need actually to reverse this many times. I think there's the second reverse you have here has to be a reverse first instead. Or you do it like this. It doesn't matter. And then remove the first reverse. The left. No, not that one. No, opposite.
That's
the one on the left. That one, and then you still need to reverse at the end. Before the omega. I mean, I told you it's gonna get ugly. I just thought that there was a language that this solves the problem in a weird way, but it doesn't properly solve it because if you have spaces in your text, it's not gonna work properly. So then you have to put in some like weird placeholder values. But the point was, if you have a language that has like a list array model and it allows you to transpose a list of lists and it does the zipping, then you can solve this in a different way. But never mind. EPL is not the right language for that method.
Well, we've got 6 minutes left because I can't go over too much longer today. Should we talk about short scope, long scope, or should we defer it to next episode? How far can we get into this discussion in 6 minutes, or 10 if we go over a little bit?
We can open up the subject a little bit. I mean, what is it to say about it?
Well, so while I was going through the solutions to this problem, it struck me that BQN required parens. I mean, initially I solved it without parens, but if we get back the solution, which is 1 plus range composed with length in parens backhook replicate. I guess you were saying if I do this and this, which is add, what? It didn't work.
No, but it has to be on the top, right? It's one, and you can't use jot like that in PQN. Right. You're mixing up with APL. So you have to to use the bind thing, and then it have to be on the top. Yeah.
So we got rid of the two parentheses.
Length, you got rid of the parentheses.
Yeah, we got rid of the parentheses by adding a what looks like a back hook, but is a overloaded back hook to be bind with the 1 plus. And so I guess I've never really fully grokked, how to parse modifiers versus functions in the array languages, aka operators versus verbs, or whatever you want to call it. And that's because, that Wikipedia page, APL Wikipedia page, or I guess APL Wiki page, references that modifiers have long left scope and functions have long right scope. So that means that the back hook to the left of replicate here takes everything to the left as long as a function keeps encountering another modifier on its left?
Yeah. Or it doesn't have to be a function. As long as you've got operators to the left of every non-operator. Because you could also have constants in there.
Here's a plea. Is it to 𝗔𝗍𝗪? Did 𝗔𝗍𝗪 create this? We got a dialog APLs is by far the best explained. J's is not bad either. Although I guess I'm just used to seeing it horizontally like a Christmas tree or like a kind of chandelier. But BQNs, this is the hardest to... I guess it's is it the hardest to understand, or is it just the least visually pleasing? But I mean, what if we do this in APL? Will this have? I mean, I guess that's the thing, is we don't need to do this, but let's just, for the sake of argument, pretend. Actually, let's just create an iota. Ooh, there's a bug, folks. So many bugs. Let's just leave it like this so it looks better.
What are you trying to do?
We're going to do a 1 minus iota. So
why don't you just set quad.io?
You're a genius. Why don't I do that? Because I never do that.
Okay.
And so now if we do this...
Yeah.
This works as well. And so now...
Yeah, of course. Yeah.
Ooh. Zoom out, folks. There we go. And... I guess it's simple enough to understand. Why have I struggled in the past to understand this? You know, what is an example of if we do some...
If you want arrays or something, you can do like just something simple would be like one. Huh?
So like this fails.
Yeah, this fails because of this.
Right.
Yeah.
So what I put on screen was catenate over plus reduce. But because reduce is a modifier, it looks at the function on its left and then takes that. But the function on its left is also going to look, is there a modifier? So I guess it's just this pattern that it looks for basically modifier something, modifier something, modifier something. And as long as it has that pattern,
You can have multiple modifiers.
you can have multiple modifiers. What does that mean?
And you can have a sequence of modifiers, because you monetic modifiers. Whatever you want to call them.
Right. I see what you mean. Like,
And
each
yeah.
plus reduce each or something like that.
Yeah, and you can have, it doesn't have to be functions either. You can use arrays, array operands. So here's an example of that, just a simple example for you. If you type like 0, just clear out everything, just to see an example of no functions. 0 at 1. Yeah. Behind 𝗦𝗢𝗪. Yeah, 10, 20, 30 or something like that. Doesn't matter. 8 to 3. That's fine. So what's the structure here? What's going on? You can remove the 10, 20, 30 and see the tree diagram for it if you want. I'll do that. So we start at the 0 at 1 behind 𝗦𝗢𝗪. So we start with the 𝗦𝗢𝗪. It gets bound by the behind. It goes further to the left. There's a 1. Are we done? We don't know. Keep going to the left. There's an @ Okay, so this @ takes the 1. Are we done? Go further to the left. There's a 0. Okay, are we done? Go further to the left. Oh, there's nothing more. We're done. But we could keep going like this, right?
Yeah, I guess it makes sense. I mean, it just if I can type correctly, range, jot, length.
You still say jot.
Is it not
Well,
jot?
it is a jot. The symbol is a jot, I guess, or a ring operator, whatever you want to call it.
Yeah, I guess.
This diagram is not really hard to read, right? What it's saying is that first we bind together the range atop tally, count, whatever you want to call it, right? And then the result of that gets passed into the plus that also takes as left argument the 1, and the result of that gets passed into the behind what's called before. That also takes the replicate copy.
I guess here I'm trying to distill why I think the long right scope of functions is more intuitive than the long left scope of modifiers. And I think it's because if you remove the parentheses on this expression and you just have 1 plus range, jot, length before replicate, the long right scope of this modifier stops when it encounters 2 functions in a row. Like, there's rules for what ends the long scope of a modifier, where, correct me if I'm wrong, the long right scope of a function doesn't really have like that equivalent thing. It's just always, if you've got a reverse function, evaluate everything on the right. Doesn't matter like what order or whatever, just evaluate all. And then when you encounter it, because like this,
thought about that.
Like, I had never, until we started having the conversation with, was it Jacob in the last episode, and I came across, we were talking about the precedence, and this actually came from the discussion with Ben, and there was someone in the GitHub discussion of that ADSP episode that mentioned, it's ironic, or I find it whatever, and I brought that up in, so there's a lot of bouncing back and forth between ArrayCast and ADSP. But someone mentioned that there is precedence in array languages, and we don't acknowledge it. And that made me think harder about the fact that I don't really fully understand the parsing rules of modifiers. And a lot of the times I just kind of start writing the expression, and as soon as it doesn't work, I know, well, I need to parenthesize it. I don't ever think, as long as I bind it, and as long as I add another compose here, or a B combinator, or a B1 combinator, I'll be fine, and I can stay parentheses free. I've never really thought that hard about it, which is probably not good. I should think harder. But now that I am thinking harder, you said that, like, what is there to talk about? There's no difference. And in my head, I'm thinking, no, there is a difference, because I never had to think about it with the long right scope of functions. It's like it's even simpler than being intuitive. You don't even have to think about it. It's just evaluate what's on the right, and you're good to go. Whereas there are cases where if you're not going to think about it, which I should have. I apologize, folks. I should have thought about it, and I would have never had this trouble. But I guess because I didn't think about it, maybe a couple of the listeners are going through the same learning moment that I'm going through here, is that the juxtaposition of functions ends and I'm not even sure if that's just the totality of the list. There might be a longer list, but there's a list of things that like end the long left scope.
No, I think you're right. It goes, well, if you go to the left, towards the left, it's not actually true that it's the juxtaposition of two functions, because if you replace here the range with a number, it's not very meaningful. But here the buck also stops f to the left of that number.
But now it just parses correctly?
No. Exactly same parsing. The number stands in for a constant function. So I think the important part here is not that you can't say that's two numbers together, two functions together. That's not even what it is. Because if you go back to the range as well and remove the plus, it also stops to there. It doesn't make sense here for this definition. But what's actually happening here is that the application. So now we got one range at top, tally before replicate, which doesn't parse correctly because of a train formation rule. But if you can put the number back there, the one back, and put a right tech to the far right or something like that. Anything to the far right. No, far right, other right. Yeah, that one. Right. So what's happening here is just because of the how trains have to be formed. So now the overall derived function of range at top tally before replicate is diagonally applied. Right? It gets the one as left argument. So the long left scope of the before stops there between the one and the range.
Right.
So that's not it. It's not the juxtaposition of two functions. It's not that's not it. It's you have, and this is how I think the dialog parser works as well. It looks behind or looks ahead, if you want, to what's the left. You say, what is the next thing there? Is the next thing on the left something that will grab this token, or are we done? Right? So the only thing that can grab is the dyadic operator. A monadic operator only works towards the left. A function is on its own. A constant is on its own. The dyadic operators, they grab to the right, hard.
I mean, is bind, is that technically in the classification of dyadic operator?
Absolutely. Oh, yeah, for sure. You can. Yeah, it is just another operator that you can just define yourself. It wasn't always in the APL, but you could totally define it. We could do it right now if you want. It's super simple to define what bind is like.
Yeah, I guess.
It's easy to define the two cases on their own. Like if you go to in APL, I'm mostly familiar with this. If you switch to APL, we'll define one of the two cases of bind, right? So bind. If you want to have a constant on the left, huh? Oh,
sorry, I was BQN typing mode.
Backslashing, yeah, right. So let's just say we have the array on the left and the function on the right. Yeah? Mm-hmm. So all you want to do is the left operand, alpha alpha, and the function, which is the right one, omega omega, and the right argument omega. Yeah, that's bind with array on the left and function on the right, and bind with a function. Yeah, you could write. What do you? Oh, I see. One bind. Yeah, this is fine.
Well.
Yeah. And the other one would be exactly the opposite. It would just be omega. So this is reverse bind or whatever you want to call it. Yeah. Right. So then we just swap things. So we've got the function that we're applying is now yeah, I guess
Like that?
Yeah. Yeah. No, they got alpha alpha and omega omega swapped, right? Because the function is on the left now, and the array is on the right. Yeah, like that. So can you do -1? Just define -1. It should be minus bind C1.
Oh, right.
You can't do that. It's monetic. Yeah.
I wanted it to be English, but
You can't do that.
for this last section, folks, just head over to YouTube. We're not going to bother explaining.
You can't. It doesn't allow you to output like that, does it?
Very sad.
Yeah. Anyway, it doesn't matter. You're only getting the last result. I don't know how exactly this is implemented, but so they're very simple, right? So the only thing missing to define the full bind operator is you just check the syntactic class of the operands. Right? If you want to define a cover for this 𝗔𝗿𝗏 in the most obvious way, yeah, right? You check if you got an array on the left, then you use the right, bind definition. If you got array on the right, yeah, you do that. And if you got function, then it's the beside operator. Then it's just alpha 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 omega omega omega.
Well, we learned a lot, folks. Hopefully you learned a lot too. Thank you for the lesson, Adam. I am now.
I think you're right. I think there is a thing that it's harder to see how far things reach for operator binding than it is for functions taking long right scope. But there is also a limit to that because functions stop at right brackets of all sorts, right? Right square bracket, right round parentheses, right curly brace. That's where they stop. Or a diamond.
Right.
Or a new line. I mean,
yeah, there's just something, like I said,
but it's fewer, right? You've only got 5 things that can stop the right scope of a function, whereas you've got a ton of stuff that can stop the left scope.
Right. Yeah.
And I have thought about it. Let's do that with a closing word because I know you need to go. I thought about a more graphical input and display and manipulation of APL, where sort of like Scratch, the Scratch language. Mm-hmm. So imagine if the symbol, so to say, for an operator, for a dyadic operator, was like a colored block that had the symbol in the middle, and then it has 2 slots for the right and left operand, and you put something in there. So I was thinking of it like a actually wonder if this still works. You have a couple of minutes? It's okay.
A couple of minutes.
Or do you take another time? I wonder if this is. I made something like this a long time ago, and see if I can still find it.
Are you going to share your screen? So I should stop presenting.
Yeah, I can. Yeah, I guess I can share my screen. Let's see. And I don't remember how far I got with this, so you'll have to bear over with me. But maybe I should keep it so people can go play with it. So this was just a little example, sort of like your like your array box type thing. That's something I was playing with here. I think it is. No, not that one. Second here. Okay, so my idea was that we take API expressions and you sort of transform them into this new form that I wanted to have. So see this?
Mm-hmm.
So notice the rendering here of the commute operator. That the whole block is the commute operator, and it has a slot where it takes the function. Now it's not hard for you to parse anymore, right? It's not hard for you to see whether the 255 is included in what the commute operator is working on. It's not hard for you to see where things stop with the reduce here.
Right.
Because you have the frame around it, sort of like it's parenthesized, but not really. Now, does it work on everything? I don't remember exactly. So let's, if we do something like plus dot, I'm not sure dot works, but we can plus dot times each reduce or something like that. I don't remember how far I got it with things. So it's not perfect. Maybe let's remove this just for a moment. Okay. So here you have a dyadic operator, right? Or we could use power for that sake. See, it has the two slots. Now, if we do something like this, yeah, this doesn't quite work. It doesn't. I mean, I didn't finish this. It was an experiment.
I get the idea, though. Is it visually shows you like what
it was
a
supposed to be
modifier
like
operator consumes.
Yeah, this is completely broken. But the idea is that you have the two slots, and then if you're inside that slot, you have another operator that then it would have its own slot, and the boxes sort of grow and scratch with scratch style, and there, you know, have no problem at all with the long left scope because it's immediately visible.
Right.
And yeah. I even a further thought of this, and that you can sort of see it here as well, is that you don't need parentheses anymore because you could have like a no up box. That is what a parenthesis is. There's no reason that the parenthesis is drawn only as left and right borders. It could go all the way around as well. That's just a box that nothing can grab through that box. Right? So you see the modules of the pieces of the code.
Yeah, something like this, yeah, would be really cool. I mean, I'm dying for. I'm not dying. I'm totally fine. But I would love all of the array languages to have. I know Cap has something built into their GUI version, but I would love TinyApple to have an explain as well. But what I would really love is a way to mechanistically like annotate functions. Like, so you could imagine in Dialog APL, if I wanted, I could say, you know, if I put two comments after every, assume all tacit functions, I guess they have to be, are one line, you know, so you define a bunch of tacit functions and I put a double comment after a double lamp and then just like an emerald. And so, you know, some mechanistic way of saying, treat this as a monadic function, treat this as a dyadic function. And then at like, not at a program level, but just whatever you're doing in ArrayBox, you could imagine that if I'm going to go and show some tacit expression that's formed from these other tacit expressions, if you have a way to tell ArrayBox whether this tacit thing should be treated monadically or dyadically, I can then go and like super annotate the train tree so that like in the top left corner of every 3-tine or 2-tine, which represents a 2-train or a 3-train, I can then put like this is a phi or this is a phi 1. And that would be like, I think, so useful, even if it's just for like pedagogical, like teaching purposes. Because I know that like 90% of listeners.
I mean, there's no reason you can't build this, right?
Time is the reason that I.
Yeah,
and like what I'm hoping
there's
is
nothing in the language that prevents it itself.
No,
like,
exactly.
Obviously, you can't execute that. But for example, in APL, you could use like a subscript 1 or 2 to say whatever's on my left or right or whatever is monadic or dyadic, and then for execution purposes, those symbols are just removed, but it works as an annotation.
Yeah. The thing is I don't really want to go build it for Dialog APL because then I feel like I have to go build it for J and for BQN and then for Tiny APL, Tiny Apple. If Tiny Apple gets one of these, what I'm hoping is that Jacob will keep working on Fix APL, and then I can just get he'll build one, and then I can very easily, because whenever you see a certain pattern, it's just going to map to one of the combinators.
Yeah,
Something like this,
you just use it.
yeah, would be very cool.
But isn't it backwards? Isn't if array, if the notation is a tool of thought, we shouldn't have to mangle what we write. Well, I don't know.
Well, we have to because of
express
ambivalence.
ourselves.
We have to.
Yeah. No, but that's what I'm saying. There would be better if you could directly express what you want without sort of giving hints to some system that needs to understand it. So something like what I showed, but not taking an APL expression and explaining it, but going the other way. I want to start with the explanation. I want to tell the computer what to do. And maybe it makes for some fun graphical thing like Scratch, but let the computer work hard to understand what I want instead of having me to work hard to tell the computer what I want. So if I had a way to like say, okay, I have this operator, and then I would, let's just say, imagine a user interface where I've got an operator and I have some function written out, like you had like the BQN thing, and you select the part of the expression that I want to be the operand to that operator, and I somehow like invoke keyboard shortcut or mouse or whatever to say like, okay, bind this with that, and then it would draw some boxes or whatever it needs to do, change the colors, and it knows that, okay, that's the operand for this operator. I don't have to worry about parentheses. I don't have to worry about binding strength and so on. I told the computer, this is what I want to be the operand for this operator. Deal with it. So I can just.
But then you're just saying that like the code is like a visual representation using colors and boxes and stuff, or
it could be, yeah. For example, you would draw a little box around it, say, okay, no, I know, yeah, that's the operand for this operator. Under the surface, maybe there could be some intermediary level notation for it.
Yeah, maybe. It's food for thought, folks. We really do need to wrap this up, though, because my wife is waiting for me if she hasn't already left for the evening.
Yeah, same thing here.
Anyways, we usually wrap up by saying you can reach us at contact at
arraycast.com.
Yeah, Bob left. We don't get any emails.
I haven't been the same.
Contact at arraycast.com, and yeah, we will have another episode probably in a couple weeks. Subscribe to our YouTube channel to get notifications. We will choose predetermined date, but for the moment, just assume it'll be Saturdays, unless if you hear otherwise from us.
Eventually, it will be hard for me to make a time that's convenient. So it gets later and later that I can be available.
Oh, okay. Well, we will find a way to make it work. Yeah, a different time. But yes, thank you for the people in the live chat. We will look forward to hopefully seeing you in the next one. And with that, we will say happy array programming.
Happy array programming.
That one was pretty good.
Good. We'll get there eventually.